I think you are advanced for them. Sorry, so now I'm going to get some. So italiano, però meglio che parlo in inglese per me. So today I'm going to talk about libbitcoin. It's a project that started in 2012, and one of the early founders, Amit Taki, is very much involved in Bitcoin from the early days. And libbitcoin has gone through a number of evolutions in terms of the architecture and the design, but it's always been C++. So today I want to just quickly give us an overview of what libbitcoin is about. So talk to you about what are the goals and motivation of a library like libbitcoin. Why does it exist? If we have Bitcoin, why do we need another implementation? I'm going to give you a quick overview of the libraries, and then hopefully motivate some people to either try to use it, or find time to try to contribute to the project, because we do need a lot of work to be done still. Okay, so this is what the talk is going to look like. We're going to go through the motivations, the goals. Then I'm going to talk about the stack of the libraries, because there's a number of components, number of repositories, and I'm going to go through them one by one. Then I'm going to talk about very quickly how we could use the APIs in C++. And then we have a command line utility called the Bitcoin Explorer, which is very popular. In fact, I don't know if you might have heard or read the book Mastering Bitcoin by Antonopoulos. He uses the Bitcoin Explorer a lot to talk about the examples. So that is one of the primary uses of Bitcoin in popular culture. Then I want to talk about the current and future work, as to what we need to do still and where we want to be, and then conclude. Hopefully, we won't be more than half an hour, 40 minutes. Sorry, I'm not getting into this. Okay, so that was what I want the talk to look like, but eventually I want you to get the message about why libbitcoin is interesting, is because it has this component architecture which kind of makes it easy for us to develop the thing, because we divide different responsibilities into different repositories, and we can test them in isolation. And B, very importantly, that you can, or developers can use any section of, or any component of the library, and then develop an application with it. We're going to look at more details through it. Right, and the other thing is libbitcoin is very much focused on vertical scaling of a Bitcoin node. What we mean by vertical scaling is that when you try to sync a Bitcoin node, it can take a few hours and things like that. But what we want to do is, if you have a machine which has more powerful CPU, like 16-core processor, and has 256 gigs of RAM, then you should be able to download and validate the whole blockchain faster. Currently, other implementations are not so focused on this aspect of a Bitcoin implementation, but our focus is very much strongly for backend services, so that you deploy the code base, you run it, and then you can sync the blockchain much faster if you have a heavy, big machine. Okay, and going by the same theme, we are very much focused on the backend. So we have a lot of API interfaces. The core is using 0MT, which is a C++ library for in-process communication. And then on top of that, we have WebSockets and JSON RPC APIs. Because it's C++, libbitcoin is cross-platform. It works on Windows, Linux, and Mac right now. There are bindings available for Python, though they are kind of not maintained because it's a contribution by some developers. There is build support for Android, so you can throw libbitcoin code inside your Android app and then build it and link your app with it. And someone recently has started work on an iOS layer as well. He's using the C bindings on top of libbitcoin and then calling it from script. So there's a few interesting things happening here. Now I'm going to jump into why we need libbitcoin, right? The problem is that application development with Bitcoin is hard. Anyone who's tried to do it, you end up pulling your hair out, right? You have to write your script, chunk of a script, then debug it, then build transactions that use that script, then broadcast that transaction to some node. Then once you send out the transaction, you need to be able to get events from a node, and all this, everybody has to do it again and again, right? You want to query if any payments were received on a certain address, right? So there's applications out there that do this every time, again and again and again. And you want to query the blockchain, what is the balance on a certain address, what is the balance on a certain script hash, and things like that. So as I was saying, a lot of applications end up reinventing the wheel. So the most popular ones, for example, ElectrumX, which is a backend server for Electrum wallet, they need a full index on the addresses, and they run their own process to index the blockchain by addresses so they can answer the queries for that. Then you have Insight like block explorers, which again need to index the whole data blockchain with different parameters so that they can actually satisfy their use case. And then again, the front-end libraries, which are the most commonly used ones, which is how do you build a transaction, and how do you broadcast it, etc., even from the front end. And that becomes challenging because a lot of times people are writing their libraries from scratch, and that is probably not a good idea. In crypto, you just want a long, stable code base that's been really tested and use that. And libbitcoin goes back since 2011. So now what does instead libbitcoin want to do, right? Libbitcoin already indexes transactions and addresses by default, right? I'm going really deep into Bitcoin at the moment. I hope you can stay with me a little bit. We index the payment histories, the payments, so you can query if what are the payments that went to a certain address. We have, as I said, JSON RPC, WebSocket, and ZMQ interfaces, so you can query the server quickly, right? And as I said, we have vertical scaling, and in some tests, we've also even seen a 15-minute sync time for the complete Bitcoin blockchain on a 64-core 256-gigabyte machine, right? So if you have a big fat machine, you throw libbitcoin on it, in 15 minutes you have the blockchain ready to go with all the indexing done, right? But it's only in test, so I won't hold you to it. So ideally, it should be less hard to develop script, right? So what libbitcoin has to do, it provides very robust, thoroughly tested, long deployed crypto primitives which handle, buffer management so that you are not opening yourself to certain attacks. We do key generation, we do signing of the keys. All those key primitives are there, right? And so you can just link your library to a C++ library. You don't need to use a Java library or a Ruby library or a Python library. What you can do is you write your code once and you link it to any platform that you want to use it. And we have a thing called a script machine, which is kind of when you write a script and you want to debug it, what you can do is from the command line or even from a program, you can see how the script will run and what will be on the stack. And that's kind of very handy. There's very few tools that do that. And also, libbitcoin should be portable to other build environments, right? So you should be able to use it on Mac, Windows, Linux, whichever you want to use. There's other Python contributed libraries that I talked about, and C and iOS libraries. I already covered this. So now I'm going to give you a scale picture. So, but it's not that scale. I'm going to go through these boxes one by one, right? So the gray boxes up there are third-party dependencies that we need. The dashed arrows means they are optional dependencies, so we don't need them. Then the blue boxes are the common libraries. It's the libraries we use both on the client and on the server side. And the green boxes are what you get on the client side, right? As it says, client with big black circles, big letters. And red are the backend libraries, which are libraries used to build the Bitcoin node and build a server on top of it. And so we'll go through one by one. Right? System is what provides most of the primitives that I already mentioned that we talked about. Like it has buffer management, the serialization primitives, the signing of transactions, the verification of transactions, generating HD keys, all the features that you need for doing the front end, generating transactions and broadcasting them. So all that goes into system, right? But a lot of that stuff is also used in the back end because we need the script verification, when we do the block validation and all that stuff. So that kind of goes into a library called libbitcoin system, which is the common library. It's like the mother of all libraries here. It's one of the oldest libraries as well. Right? Then you have this thing called network, which basically is abstract interfaces to implement peer-to-peer networking protocols, right? And it is used by both the Explorer and the node, and I'll talk about more how they do it. But the Explorer is the Bitcoin Explorer I talked about that's mentioned in the Mastering Bitcoin book. uses it just to send the transaction. So it's just doing that simple thing from the front end. Whereas the node uses it to implement the block synchronization protocol, the header synchronization protocol, and then transactions in and out protocol. So all that other details are used by node. But network itself just has an abstract interface which everybody has subclasses from there on. The protocol is not the Bitcoin protocol, but it's the protocol between the client and the server. So it's a protocol that's used by the client and the server to talk to each other. So client wants a query, says give me a payment history for this address, and the server replies right, but this is the protocol that implements it all. Right? It's based on 0MQ, so it's very fast. You link it, and it's one of the fastest IPC batteries out there. And it is, the authentication and authorization is secure during CP, so it's rock solid in terms of being secure. And now in V4, which is the new version that we're building, it provides a WebSocket API as well. So if you just do your front end in a browser and you point it to the Bitcoin server, you would just go out of the box and you have the WebSocket API available to you. Now, database is one of the biggest crazy things in Bitcoin. It's basically a memory-backed database store. So we don't use LevelDB or any of the other existing databases, right? It's a custom-built database for the purposes of storing and being able to quickly query a blockchain, right? So it necessarily supports parallel updates. So you can write multiple transactions at the same time, update multiple transactions at the same time. You can validate various blocks at the same time. That's not necessarily true, but some parts of the validation can be done in parallel. And it's memory mapped, so that if you have a big machine where the RAM is bigger than the blockchain size, your entire blockchain could, in theory, be in RAM, right? So imagine how fast that can be. So that's the kind of vision that the original authors of Bitcoin have had for a long time, which is pretty impressive. It's challenging, but it's impressive and meaningful. Parlo italiano. Okay, so the database also manages indexes on blocks, transactions, and payments, which is like what I talked about, the addresses, so you can query the history of payments on an address. It's append only, so that if we get a block which has valid proof of work, we never delete it. It always stays in the database because it has valid proof of work. Someone tried to attack it, the blockchain, whatever, but it's a valid block, it just stays there. It doesn't go in the main chain, but it stays in one of the side chains, and it stays there forever. So the database can grow forever. We're well aware of that problem. And so consensus is a library which just wraps around the Bitcoin Core's implementation of consensus algorithms, so that not algorithms, sorry, the consensus critical rules, so that even though Bitcoin comes with our own verification scripts and validation scripts, if someone wants to is kind of being paranoid and wants to really run the same code that Bitcoin Core, Bitcoin implementation is using, then you can just compile the whole libraries with that, with the option of with the consensus, and then it just links to those files instead, so that you get the same consensus critical rules in there. And then there is the blockchain, which is basically it's like the coordinator. It has all the algorithms on how to download a block, when to download a block, when to reorganize the chain. If a new block comes in, it updates the database. It basically reads from the database to satisfy queries from the server. So blockchain is basically a layer on top of the database, which has all the blockchain-related logic in it, right? There's a few things that are still to be implemented, like transaction pool and block templates, but we can skip that for a moment. But more interestingly, it also notifies the node or the server when there is anything that they're interested in listening to. Right? So if they say subscribe to this updates on this address, then the blockchain will actually notify the server or the node. So node implements the peer-to-peer protocol using the network library, right? So it does all the implementations of various versions of the Bitcoin peer-to-peer protocol, and that all goes in here. It's a fascinating library to look at. If you ever look at the code base, it's very nicely structured. It's very easy to understand. I mean, that's why I got involved in the Bitcoin. It's just You can understand what Bitcoin is doing by looking at libbitcoin's code base, as opposed to get even more confused. So the server is another kind of node, you could say, because it's subclass is node, but then it adds other things. It provides the query APIs that the client can talk to, because it implements the protocol interface, and then it provides all this authentication and authorization, as I talked about. It allows the client to publish a transaction. It updates a client with an event if there's a matching event that they're interested in, and so on. And client provides classes to talk to the server, which is not very interesting, but that's what it does. Someone's got to do it. And then the Explorer tool is the command line interface, the CLI, that actually provides an interface to a lot of the system level primitives, right? So remember when you said you could generate keys, you can sign transactions, you can verify transactions, you can do all those kind of things. But the Explorer is the utility. I should have mentioned earlier that the channel boxes mean that these are executables that are provided. These are programs that you can run from the command line. So Explorer lets you interface or use the libraries that system provided, where you were creating keys or generating hierarchically deterministic keys and generating transactions and broadcasting transactions. So it provides all of that, right? And there's another thing which you can query the blockchain from the Explorer. So you can say all the query parameters that client provided to say, okay, can you find me all the transactions matching these certain conditions? Then you can run from the Explorer from your command line and quickly find whatever you're interested in. You don't really need an app or a program to do it, you just have it in the command line. You can specify various servers that you can connect to. libbitcoin actually runs some public servers, so you can connect to those. They're open for read access. There's no traffic limits at the moment, I think. And you can just query and see what there is, whatever you might want to play around with. Now I'm going to get slightly more technical, and I apologize for that. I'm going to be very fast with this, right? So that you don't have to read before there. So, how many of us have done any C++ programming? I had given up ages ago, but now I'm back. So here we take basically, I'm going to go very fast so that people are not losing English. So what's happening here is I'm just trying to show what the system libraries can do from a programmatic interface, because that's what we want libbitcoin to be able to do, to provide developers tools to build applications, right? As opposed to just reinvent the whole wheel again, as I said. So what's happening here is you have a random seed, you generate a private key, you get a public key from it, and you get an address from it. And then you can print it out. It's basically a string at the end of it, you get an address from a random seed. There are classes that do mnemonics. I'm just going through very most relevant use cases that you might see. So you take a random entropy, and then you can generate a mnemonic out of it. Voila. And you can do that from command line with the Explorer, or you can do it with the libraries in your application if you want. There are classes for hierarchically deterministic keys. You get a mnemonic, you get a private key, you get a children private key, grandchildren private key, and so on. Similarly for public keys as well. You can create transactions. Happy days. It's an empty transaction. You set the version and you print it out what it looks like. Very simple. But you can set inputs to a transaction. This is where it gets going to get even more cryptic because it's got underscore zeros here everywhere. So you get your hash, you get an output point, you set your previous output, you set the sequence, and then you push this input into a transaction as one of the inputs of the transaction. Right? You can create output scripts using patterns. So we have things like key hash pattern. You put the address, and it automatically generates the output script for you. Or you can do it manually if you want. If you're doing some fancy output script, you can do operation level, output level scripting like this, right? Using CPU, just push type in of the operation that needs to go into the next space. Then you can set the transaction outputs. You take an amount, you pass it into an integer, you You set in the output and you put the output into a transaction, nothing fancy. You can sign the transaction input for a transaction by doing the whole thing again. You get the private key, you get the payment address, you use the pattern to generate the output script, and then you can sign it. You call it create endorsement, basically, because you are signing that output for that input for that transaction. And you can, of course, have all the support for different types of state hashes. But again, let's jump over that. Then you can set the script to the transaction output so that you're done with that. You can use the client to broadcast the transaction. So if you're building your wallet with C++, you can just say, okay, I want to now broadcast this transaction with the network, please, and the client will talk to the server, and the server will talk to the blockchain, and it'll all go away. If you want to query the blockchain, you can use, there's a number of ways to do it. Some are advisable, some are not advisable. You can use the client, which is the most sensible way to do it. The client will talk to the server and get things back. You have API calls like transaction fetch transaction, blockchain fetch block, blockchain fetch block for a height, for a hash of the block. You can also query the history of a payment. You can give it an address or a script hash, a bit like what Electrum does. This is new in the new version of libbitcoin, and we'll just query the whole blockchain and then just give it to you. But you can skip the client, and this is not advisable, but you can link directly to the server. So if you're building a backend service which really needs close interaction with the server, you can just link to the server library. Nothing stops you from doing it. And then run these calls to fetch blocks instead of going through the client-server protocol. You can just link to the server directly. So you're building a new server, right? Or you could even link directly to the blockchain or the database, whatever level you're interested in. You can just link to the right level of the library and do what you want for whatever reason you might want to do it. But it's there. That's how I see it. So basically, what you would say is using ZMQ and the client system libraries gives you a lot of power to do a lot of application development quickly enough, right? You can build your SPV wallets, you can build your Lightning Network client, you can build clients that subscribe to certain events from the blockchain, like something like watchtowers, right? You can just do it because everything is, the facilities are all there. You just need to compose them by the new rules that you want to respect, right? And that's actually from what Node Server and Node Server libraries do as well. You can build applications like Block Explorer, so you can have to do everything from the ground up. You can build services which are watching certain addresses, like payment processors that want to know what's happening on the blockchain. You just get the events quickly, build everything from scratch. And so database and blockchain APIs. Database API is very intriguing because you can quickly do your chain analysis if you ever wanted to. And remember, because the whole idea of separating concerns is so we can develop them in isolation and test them in isolation, and you can use them in isolation if you want to, right? So that's it. Now the Explorer is only one slide. It's getting out of here very quickly. So these are kind of the simple commands that are mentioned in a lot of posts online in the book Mastering Bitcoin. It's a super powerful tool. There's none equivalent to the Bitcoin Explorer at the moment. You can generate your keys, you can fetch your transactions, you can fetch your blocks, you can query the blockchain using the public servers, you can encode, decode, you can do as low level as you want to do to mess around at the buffer level, or just build a transaction and broadcast it, right? And I would seriously advise you, if you're interested in doing some Bitcoin development with C++, to look at teachbitcoin.io. One of the contributors of libbitcoin is running an online course, and it's actually pretty good. It's still ongoing. So the next steps that we want to take with libbitcoin is there is some improvements we need to do for supporting SegWit. It's all there, it works, it does the minimal things, but we need to improve how it's implemented. We need to support new address formats, like Bash32 is also not there. We want to improve some of the utilities which are internally used, some optimizations really. That's in system. But the client and server are getting some big changes, right? So JSON RPC API is coming out, WebSockets API is coming out. The payment indexing using Electrum style script hashing is already committed. It's going to be in the next release. There's plans to support IPv6, and there is serious plans to support block templates so that miners can actually use the Bitcoin. Node blockchain and database have been seriously focused on speeding up initial block download, right? We really want to, Eric really wants to bring it down to less than an hour. The payment indexing, which is already there, we want to support the compact blocks so that we can actually be good members of the network. The mempool message is in the next to-dos as well, and there's internal improvements that we want to do to the multi-threaded implementation. So all this is kind of the future work that we're trying to get done to get the V4 out. There's a lot of work, and that's why I was saying if anybody wants to help. So in conclusion, I hope you got a sense that this is a component architecture with a strong focus on vertical scaling. There are multiple ways to talk to the server, right? It's cross-platform, and there's a number of language bindings available. And with that, I think I'm done. No. Amirzaki is the guy who started it all off. Hats off. Eric Moscow has been doing amazing work with all the multi-threaded work that has happened here. It's like amazing to see all the code there, and it's amazing to see how he helps new developers as well. James is running Teach Bitcoin, and he's helped me a lot, so I want to acknowledge that. And Neil as well, he's one of the co-contributors who's helped me with the presentation. So thanks for that. And this is the GitHub, the Slack, and that's me on Twitter. And that's it. I'm sorry. Any questions or?
Couple of questions. So regarding the consensus part,
yeah,
you said that you can just use Bitcoin Core consensus rules if you want to avoid like consensus problem. Like how does it work? Do I connect to a Bitcoin node or just import the code?
We essentially copy pasted.
So
they have a separate file called consensus which has all the rules. We copy pasted that code into another repository, put a wrapper around it, and we link to that library.
Okay.
If you had compiled and say with consensus, we link to that code. Otherwise, we link to our code.
Okay, I see. So why should I use like libbitcoin code instead of?
Because of all the other things around it, right? So the reason is some people are paranoid. What if there's a bug in one of the consensus critical parts? So to alienate that fears, our code works. All the tests are passing, right? But just to alienate that fears, if you really want to put on and want to use the same code that is running on a Bitcoin B node, then you just use only the consensus critical parts, right, in the Bitcoin. But then you get all the amazing functionalities of a faster blockchain time. You get all the indexes built, right? You can build applications by linking to the code base as opposed to talk through the JSON RPC. So there are pros and cons in both directions.
Regarding the size of the blockchain with Bitcoin, is it bigger than with all the indexes, or is it much?
It is, of course. If you turn on the payment indexing as well, it is bigger. It is, but again, our focus is not on the Raspberry Pis.
Yeah,
it's on the warehouse. It's on the data warehouses, right?
So, like, just to have an idea, like how much it is bigger compared to
the V3. I've only seen the V3 servers, right? I think it's at least 15-20% bigger.
Okay.
Yeah, it's not double the size. No, because everything is like a flag in an integer somewhere.
Okay.
So, but I mean, the implementation is kind of focused on a beefier machine. If you have larger, more cores and bigger RAM, you're going to get better performance with this. If you have a very small machine like a Pi and try to run it, might even not run. It's straightforward. So it's a different use case that we're trying to do. Anything else?
Is it possible to do a smart contract on Bitcoin?
Well, whatever you can do with script on Bitcoin, you can run here because we support all the script operands. We do the same verifications. It's exactly the same thing. But it depends on what smart contracts you build with script.
Like I'm taking in comparison with Ethereum, if it's
exactly the same as Bitcoin, right? So whatever you script you can run on Bitcoin, you can run on the Bitcoin as well. So it's nothing new we are thinking in terms of new operators or new language here. It's exactly the same as Bitcoin. We just implemented differently.
Okay.
It was not clear to me the difference between server and client. if I understand, the server implements the actual node, and the client in some way is all the part that implements the wallet and things like that. It's correct.
Yeah, you're right. So what would essentially happen is the server is the one that does the talking to the database. Okay, so it receives a query and it replies, right? So the server will receive a query and it will reply, right? The server also exports WebSocket and JSON RPC APIs, which you could be sending it to the server through an HTTP gateway, right? But you could also run a client which uses the ZMP protocol to talk to the server, right? Or uses a JSON RPC, based protocol to talk to the server. So the client is an application running on a laptop, right? And it wants to query the database, but the server is the one that has all of this information available, so it can reply quickly after the client. So they're two separate things, really.
And you say that you index all the transactions and all the data, so you can make any query to...
Well, any within limits. So we have the blocks, the transactions. So you can find the transaction by hash. You can find the transaction by block height and the index in it. And we also index, which is different from other implementations, is the addresses, right? So when you send a payment, you send a transaction to a certain address, and that is a big index to maintain, and that's what the reason some other implementations don't maintain it, and that's why a lot of other application developers end up having to re-implement that outside Bitcoin. Instead, we are building that index as well, so you can quickly ask, here's my address, which are all the payments that went to it, which are all the payments that went out of it, and yeah.
No, I think I didn't understand it correctly. I ask you to be sure. If I can make a query for an address and have all the transactions, so belonging to that address.
Yeah, exactly. Yeah, so you get all the details that are related to that address. Exactly. Sorry if I answered in a long way.
Okay.
Anybody else?
Uh,
The C++ developer. He's gonna.
I'm asking a different technology,
Okay.
about different technology. Why do not use Java technology, 0.7?
You could, but usually C++ is known to be slightly faster.
Yeah.
So, and it's harder to code, but that's the reputation that C++ has, and that's what we were chasing.
Just for
performance, and also to be able to run on different platforms, right? So C++ has a negative, that it has to be built everywhere you want to run it. You have to compile it. But that's also an advantage, that you can just compile it for anywhere that you want to run. You want to run it on Android, you can compile it. You want to run it on a Mac server, Linux server, you just compile it there. You want to run it on an IBM server, you just compile it. So it's actually portable.
Okay.
If you apply your stuff to it.
Okay.
Write once, run everywhere.
Thank you.
Sorry,
The minimum requirements for the server.
I don't have it here, but on the wiki there is a comparison between the performance comparison between a big server and a small server. Which small server has an 8 gigs of RAM, and it's an Pentium i7, and it works. So now your laptop should be supported. It will be slightly slower than the server, of course, because that's the goal, but it will work.
And regarding the indexing part for the Explorer application, is it possible also to search for particular scripts output?
Yeah, that's a very good question, right? So I actually have it here. This is something that we just recently implemented, so it's very fascinating that you ask that. So, because Electron does that, right? So the version 3 implementation, which is in production right now, indexes addresses. But as we realized, as people have realized that indexing by addressing can be ambiguous at some point. So what Electrum does is takes the SHA-256 hash of the output script and indexes that. And that is what we've implemented as well now. So in the V4, we won't index by address, but we'll index by the hash of the script, of the output script. So and we will provide, and we have also, it's already there, that you give us an address and you say, oh, can you treat that as can you find me all the instances of this address for pay to public key hash or pay to script hash, whatever. So we have those templates, we put that address in there, we generate the script, we generate the hash of the script, and then query the database because the index is on the tab.
Like, can you also look for all the outputs that respect a particular template? So maybe I'm looking for like output with particular scripts or something like that.
No, because you'd have to give the hash of that whole thing, or we can do the template part. But like the problem is, what do we fill in the blank? Like say you give us all the transactions matching K to public key.
Yeah.
But then you have to put all the addresses. So another index that just indexes just the templates of the.
Yeah.
That's an interesting thought, actually. Do you have that use case?
More like if I'm looking for exotic like scripts, somebody is using them or something like that. I'm not sure it's very useful.
Yeah, but it's an interesting idea actually. It will be one the public key or pay to script hash will be very long the response.
I mean, maybe it may be more useful in the future if more scripting capabilities are added to Bitcoin.
Yeah.
So I may want to look for like certain.
No, totally agree there. Yeah, it's an interesting.
So basically, I guess you will just have to hash the template without the keys or timings or stuff like that.
It will probably be a different index.
Yeah.
Yeah, sure, can be done. A bigger, fatter database, sure. So yeah.
Just a question about data management. Because one of the main concerns about public administration to adopt this kind of technology is related to the new regulation about the so-called GDPR. And one of the main disadvantage of blockchain is related to the data that will be retained for a long time, and they will never be deleted because it is used to the main algorithm to check if a transaction is authorized or not. So what are I don't know, we can say some tricks or maybe some workarounds to carry on with this regulation and to let the owner of the data to be deleted entirely from the system?
I mean, that's gonna be, it's a question that, to be honest, I'm not too informed to reply, but I'll take a punt. With Bitcoin, basically the transactions are noting the public keys that the payments are going to or from, right? Now, how do you cross-reference it to individuals in the real world is a question that Bitcoin doesn't worry about, okay? So it's not Bitcoin's responsibility if it maps to an individual or not. So to say if someone can come along and say, this is my data, I want it deleted, of course you cannot delete it from blockchain, that's the point. But there are other arguments to look around it is to that on blockchain you should only put data that is not identifying you personally. That's not PPS, not personally identifiable data, whatever the acronym is. So I belong to that camp that if you're putting something on the blockchain, then don't make it identifiable to you because it's going to be there forever. You know how we say that data on Facebook is going to be there forever? Maybe not. Maybe Facebook will die in the next 5 years. Who knows? And all the servers will, all the replicated databases everywhere will go on fire.
Or this one.
So it won't happen. But in this case, it's actually even harder that it can be deleted. So you should be careful what you put, how you get yourself identified on the blockchain. That's why there are these new wallets out there and new systems to kind of diffuse that information. I'm pretty sure I'm not answering your question. All I'm saying is actually it's very hard, and I think there is a general understanding that it's very difficult to respect GDPR if you put personally identifiable data on a blockchain, on a Bitcoin.
So we have to avoid to put sensible data.
Sensitive data, yeah.
So only technical data, or maybe some masking the data.
Yeah, well, encrypted data that you've already. But there's Bitcoin. I mean, that's more relevant for Ethereum and other platforms. The Bitcoin, you really are just sending transactions from an address to an address, and as long as you can divorce your real world identity from that address, then you're fine. And there are ways to do it.
Okay. Sorry to change
No,
the
go on.
discussion, but I have another question. It's more technical because I didn't understand well the concept about the vertical scaling of the node.
Okay.
Because I know, if I'm not wrong, that it is based on a peer-to-peer architecture. So every node that joins the network has to validate the current transaction that is put on the top or on the top of the blockchain. So how we could increase the performance by scaling out, in this case, because the vertical scaling is a scaling out of the nodes. Because every node has different bandwidth in the network.
Yeah.
I mean, maybe
And different capabilities, yeah, there's certain differences. I get your question, right? So your question is, how will libbitcoin help scale Bitcoin, the entire network, right? And the answer is more, right? The scalability mentioned here is not the scalability of the entire Bitcoin network, but of your node. So if you are running your Bitcoin node on your little machine, on a laptop, you will get a certain performance. It will download the data, validate the data. It will take like 4 hours to do that, right? And if you put queries onto it, you can probably do a certain number of queries per second or whatever. What vertical scaling really means is that at least your node can perform faster. So when you start your node on a bigger machine, right, then your node will download the data and validate the data much faster. So that's only your node, not scaling the whole network here. You see what I mean?
Yes, so the computation is, practically we could say, is lent to a machine that could manage this hard work about the computation of the hashing algorithm called etc. So much performance about this node, less response time to the clients, isn't it?
No, I wouldn't say the less response time. Why do you say less response time? Because you're busy doing the computation? Hello?
Yes, because it's you are busy in the CPU time.
Yeah, but that's the thing, right? So if you have like a quad core machine, you can set it in your configurations how many threads you want for validation, right? So you start the validation, you say I only want 3 threads for it. So you need 1 thread available for other things. So you can do that kind of, it's in the config files. You can say, okay, I want these many threads to be spawned to do the validation. So you can have that level of control there. So, and I mean, the difference is also, which surprised me nicely was that with Bitcoin, while the node is still syncing, you can already query the database, which is kind of nice because in development time, sometimes you just get the first 1,000 blocks through the machine and start querying it.
Parallel activities.
Yeah. So it doesn't have to finish the syncing for you to be able to query the database, which is kind of neat.
Thank you.
Andiamo via, dai.
Just a question. Is there any plan, any likely implementation that is planning to also be compatible with libbitcoin backend?
The implementation of?
No, like, is there, that any likely implement, because, for example, LND is compatible with both BitcoinD and BTCD. If somebody is working on making compatible.
Well, I mean, we do have the JSON RPC, which is fully compatible with the BitcoinD JSON RPC.
Okay.
Bitcoin D JSON RPC interface, right? So you could just take out the Bitcoin D implementation, put in the take out the Bitcoin D implementation, put in the Bitcoin implementation, and you have the same API. The JSON RPC API is the same.
Okay, so it will be quite easy.
Yeah, it will be straightforward.
Okay.
But we need developers to do the V4 out, so please spare time.
Okay.
Thanks.
Education.
Thank you.